This is Mrs. Struble with Struble Math, and in this video, we're going to be working with translating and simplifying algebraic expressions. So let's get started. First, let's talk about how to translate an algebraic expression. I encourage you to pause this video and write this table down. In this table, we have our different four basic mathematical operations: addition, subtraction, multiplication, and division. As many of us have already learned in our English classes, there are words that are different but mean the same thing. This is also true when we're talking about math. So when we are talking about addition, we can use words such as add, plus, sum, more than, or increased by to signify the fact that there is addition going on. These are not the only verbal expressions that translate to an addition expression in math symbols, but they are some of the more common ones. Some words we use to signify subtraction happening: subtract, minus, difference, less than, decreased by, take away, less, just simple less. Now there is a hiccup with less than. Okay. Notice in this statement, 12 less than a number. The number that we don't know, our x, is actually first in the expression when we write it in math. Think of it this way: if I have less than you do, in order to figure out our difference or how much more you have, we would take your number minus me, even though we stated me first. Okay, so less than has what I like to call a little switch effect or a rainbow effect. So whatever is first goes behind the subtraction sign, and then whatever's to the right goes to the left. So they just flip-flop spots. Moving on to multiplication, some ways that we say multiplication in English is words such as times, multiplied by, a product of, anything that signifies a repeated addition happening. That's multiplication. And then finally, division. We use words such as divided into or divided by. We could also use quotient of or handed out equally. Okay, those all signify a division happening. So let's do these four example problems that you see to the side here. The product of 20 and t. Now, I highly recommend when you are translating words, verbal or written words, into mathematical statements, first identify the easy stuff. Identify our numbers. Where are the numbers at? The number that we see is 20. Then let's go ahead and try and figure out if there's a value we're not sure of. So are there any variables involved? And in fact, there is t. Now, t could mean time. It can mean a number of different things. These are very basic sentence stems to get us practicing translating. So I'm going to underline both the numbers and the variables. Next up is we need to be looking for any keywords that tell us what we are doing. Are we adding, subtracting, multiplying, or dividing? Here, I see the word product. Now, a product is an answer to a multiplication problem. Notice how I said it's an answer. So what are we multiplying? Whenever we see a keyword that means an answer to a problem, we have to find the connecting and that tells us what two values we are connecting with that operation. So product is an answer to a multiplication problem, so I know multiplication is going somewhere. Where is it going? It's going between 20 and t. So we end up with 20 times t. Another more common way to write this is simply 20t. Okay? Number 2, 24 less than a number. Identify the number. Those are easy to spot. 24. Identify the variable. What do we not know? We do not know what a number means. We don't know what that is. So we're going to replace that with a variable, and we're just going to use the letter n in this case. Identify your operation words. Less than. Well, less than's that tricky one. It means subtraction, but we got to do that flip-flop, that switch, or rainbow switch. Okay? So it does mean subtraction. And then we just write it out. Less than, switch swap. So 24 does not go first. It's n minus 24. All right, number 3, identify our numbers. Boom, 4, 2. I didn't even have to read it. Okay. 4 times the sum of a number and 2. Are there any variables or unknowns that we don't know? Right here, a number. So again, we're going to just give it a letter. It really doesn't matter which letter. I'm going to use n just because n starts with number. Identify any words or phrases that mean a mathematical operation, and I'm going to circle those. Here's times, and then it says the sum. Sum is an answer to an addition problem. So I have to figure out, where does that addition go? I have to find that connecting and. What am I adding? I am adding a number and 2. So the addition actually goes right here. Times, that's multiplication. Okay. Now writing it all out, starting from the beginning, we have 4 times the sum. Remember, we moved that addition over here. Okay. n plus 2. Now, be careful here, because the sum means I have an answer first. So instead of using the multiplication sign, we have to use a parentheses. This is telling us that we need to add first. We're looking for the sum first. Okay? And then we're going to take 4 times that sum. So we have to have those parentheses so whoever's doing this problem knows to add first. Number 4, we have 4 and 2. Okay. Where's our variable? Right here. Boom. Let's use the x first this time. Why not? Let's use x. And just a heads up, that's also another reason why we don't use an x for multiplication in the higher levels of math, because it can often get confused as a variable. So when you look at this statement 20xt, you at first glance, you're not really sure, does that mean times or does that mean x, like the variable? So to avoid that confusion, we put those two values together, the 20 and the t, just sandwich them together. We do not use the x for multiplication means. All right? Going back to number 4 here. Sorry, got sidetracked. Identify any words or phrases that'll tell us what to do. I see the word sum, and I see the word times. Okay? The sum. Oh, gotta find out where that addition goes. Okay, so I'm looking for that connecting word and. Whoop, he's right over here. So that addition is going to be right there. Okay. All right, let's throw it all together. The sum. Well, that adding sign moved. Of 4. Okay, so 4 would be first. Times a number. We're going to put x. And 2. So that's where that addition goes. There. The sum of 4 times a number and 2, which means we're taking all of this and as one expression. So we don't need the parentheses like we did in the previous one. So it's literally, 4x plus 2. Done. Okay? let's see how we could use this skill in word problems. Now, I highly recommend when you're doing a word problem, you might have to read it a couple of times. It depends on how difficult of a problem it is, but our goal, our objective is to determine what action is needed in that problem. Are we putting parts together, in which case they're adding? Are we putting equal parts together repeatedly? Okay, so that would be multiplication. I'm adding something over and over and over again, and that's the same thing. Are we finding how much more or less something is from another? That's subtraction. Or are we separating something into equal parts or equal groups? That would be division. Okay, all right. Let's go ahead and give these a shot. Jed reads P pages each day of a 200-page book. Write an algebraic expression for how many days it will take Jed to read the book. We know it is 200 pages. Okay, so 200 is a number that we are given, so we're going to note that that is an important piece here. What else do we know? We know he reads the same number of pages each day. What are we doing? We're taking a 200-page book and we are separating it into equal parts. We're separating it into equal amounts in days. Okay, so we're going to be dividing here. What are we dividing? We're dividing up a 200-page book. Now, we're not sure how many days, but we know that we're going to read P number of pages each of those days. Okay, so if I do this division, I figure out how many pages I'm going to read each day. That'll tell me how many days it will take. So it's 200 divided by P for our answer here. Okay, let's go on to number 2. To rent a certain car for a day costs $84 plus 29 cents for every mile the car is driven. Write an algebraic expression to show how much it costs to rent the car for a day. Okay, so how much it costs to rent a car for a day. What is involved in the cost? We have the number 84 here. What's 84? 84 a day. So for a day costs $84. So it's 84 every day, or for a day. Well, that's what we want is a day. Cool. What else is there? Not just the 84, there's also a 29-cent charge. Notice it says plus, there's a key word. We're going to go ahead and circle that. 29 cents for every mile. Do we know how many miles? No, we don't. Okay, so that right there is our unknown. That's our variable. So we're going to just say M for miles. Right? So 29 cents every single mile. Well, if I say 25 cents every single mile, let's take a look at the action needed. We are putting it into equal parts. So we're repeated addition for every mile. Well, the first mile is 29 cents. The second mile, add 29 more cents. The third mile, add 29 more cents. And it's just repeated addition over and over. So we know that the 29 cents is going to be multiplied by how many miles? The plus sign in the middle, and that is an expression to represent how much it will cost to rent that car for a day. All right, we're going to keep going here with our second objective of this video and discuss how to simplify algebraic expressions. In order to start simplifying algebraic expressions, let's start with some vocabulary terms that we need to know in order to understand them. Let's go ahead and start with what a term is. A term is all of the information within here separated by a plus or minus. So 7x is a term. 9 9y is a term. And what I like to do is remind you that this is a positive 9y, because once we get working with negatives more, that's going to come in handy to know. We have positive 15, that is a term. And then we have negative 7y, also a term. So this expression has 4 terms in it. Okay? Every expression has a term. Some other things you might see, but don't have to see, in an algebraic expression are something called constants. So constants are, simply put, regular values. No funny business. So in this example, it would be 15. In the example to the side here, it's our 3. So the 3 would be the constant. Okay, constants are just normal numbers. All right, keep going here. We got coefficients is the number in front of a variable. So in my example to the left here, we have a coefficient of 7, a coefficient of 9. 15 is not a coefficient. It is a constant because it does not have a variable or a letter attached to it. And then we have negative 7 is our final coefficient in this expression. Lastly, what we're going to be working with more so here is something called like terms. In order to simplify algebraic expressions, what we're doing is we're taking an expression that we see, such as this one we have here, and we are reducing it down to a form that's easier to read or easier to look at. Again, going to the right example here, the right side example. A like term is a term, or excuse me, a combination of terms, whether it be 2 or more terms, that have the same variable and the same power. So notice that the y squared here, if I had another, let's say 4y term, y and y squared are not the same. Okay, so it has to have the same variable and the same power. Okay. Going to the left side here, our like terms are the 9y and the negative 7y. These are like terms, meaning we can put them together. Okay, so think of it this way. Let's say Y stands for yo-yos, okay? Johnny has 9 yo-yos in this little group, okay? But then he loses 7 yo-yos. Well, how many yo-yos or groups of yo-yos does he have? Maybe it's a package of yo-yos, okay? So we had 9 groups of yo-yos. Lost 7. And then we end up with 2 sets or groups of yo-yos. So 2 y's. When we find like terms, we take the coefficient and we're just putting those together. So 9 minus 7, because that's a negative 7. So a positive 9 and a negative 7. Put those together, we get 2 as our final result. And that's how you combine like terms. Now, once we combine that like term, everything else remains the same. 7x, the 2 is a positive 2, so make sure you add that plus sign in front of it. And then we also still have this positive 15. So we went from an expression with 4 terms to now 3 terms. Yeah, not much better, but it is still considered simplified. All right. In order to know how to simplify, first we have to practice identifying like terms. So I have this nice big list here that I made. Let's talk about like terms. I like to use highlighters. I highly recommend using highlighters, especially when there's a big long list like this, and just literally starting from the first one. We have 5a. Okay? Now I'm going to go through the list, and I am going to search for a like term to the 5a. Remember, a like term has the same variable, in this case an a, and the same power. So let's take a look and see if we can find a term with simple just a. And then, yeah, there might be a number attached to it somewhere. Nope, nope. And right here at the very end, I see an a. Yeah, it has a fraction attached to it, but those are still like terms. So these two, the 5a and the 2/3 a, could be combined. And then just keep going down the list just like so. Now, the cool thing about the highlighting is however many different colors we use, if we were to combine all of these terms together, that's how many different terms we would have, however many colors we used. So we would have 1, 2, 3, 4, 5, 6 terms in our final statement. All right. Now that we've practiced identifying like terms, let's practice using that knowledge to simplify expressions. Here we go. Okay, get that highlighter. Simplify. Justify your steps using commutative, associative, and distributive properties when necessary is the key. Okay, so taking a look at number 1, it's written as 7x plus 2x. Well, we really don't need to reorder this in any way. I see the 7x, I see the plus 2x. They're both like terms, so we put them together. 7 plus 2, 9, and then the x kind of tags along. Okay, remember there's 7 groups of something over here. There's 2 groups of something over here. We're putting all the groups together. We have a total of 9 groups of x. Number 2, look for those like terms. That's our goal here first. We have a 5x cubed. Nope, that's a y. Here's an x cubed. That's a positive 7. To the next one, we got a positive 3y. Oh, there's a y, negative 2. And then x squared is all by his lonesome. So I have 3 colors. My final answer needs to have 3 terms. Let's start putting them together. Start with the blue here. 5x cubed plus 7x cubed. 5 plus 7 gives me a total of 12. And then the x cubed stays the same. Go to purple. We've got 3y minus 2y. 3 groups of something minus 2 groups of something. Well, we're left with 1 group of that something. A positive 1y. Little tidbit. You do not have to write this little 1 in front of the y. Okay, the last one is our green here. Negative 4x squared. Well, he didn't have a little buddy to be combined with, so we just write him all down. So our final result, we've got 1, 2, 3 terms, and there you go. Now, what did we do to simplify this? So it said to justify our steps. After identifying the like terms, we put them together, which means we are moving this around a little bit. So what property again tells me, hey, I can go ahead and move it around? It's the commutative property. And then we said, hey, let's let these blues talk to each other. Let's let the purples talk to each other. That's the associative property. So first we, in our mind, put them together. Put them next to each other. And then we said, well, let's let the blues talk first. Let's let the purples talk next. And so commutative property and then the associative property. Not necessarily writing those steps out, just kind of doing it in our head. All right, number 3. Uh-oh. All right, here we go. There's something happening here that we need to deal with first. The first thing we need to deal with is the fact that this guy has parentheses in there. Okay. And so we have to expand this out a little bit before we can do anything as far as putting any like terms together, if there are any. We have to use the distributive property. So if you recall the distributive property, we're going to take that value, the 2, on the outside of the parentheses, and we're going to hand out multiplication to every term inside those parentheses. So we're doing 2 times a. We're just going to write 2a. And then we're going to do 2 times the positive 2a squared. 2 times 2a squared. I'm going to write that over here. When we are multiplying a term with a variable times a coefficient, or excuse me, times a constant, like we're doing here. When we're doing this, think about what multiplication means. Multiplication means repeated addition. That means there are two groups of 2a squared. Okay? So whatever 2a squared is, there's one here and there's one here. There's two of them. Okay? And then we're going to add them together. How many a squareds do I have in total? We have a total of 4 a squareds. So 2 times 2a squared, just multiply those numbers in front is the little shortcut trick. We got 4, and then put that variable behind there, a squared. All right, oof. We've gotten rid of those parentheses. Do not forget that the 2b is also there. So we're going to say plus 2b. We still have to make sure there are no like terms. So here's an a. Do I have any other a's? Well, yeah, I have one right here. Nope, that don't count. Remember, we have to have the same variable and the same power. So this 4a is not a like term. So this guy is different than him. Okay? So we do not have any like terms. After we get rid of those parentheses, we can see that there are no like terms in this expression. It is as simplified as it is going to get right now. Last one here. Perimeter is when I have a shape and I'm going all the way around that shape. Okay, I'm adding everything together. So an expression for perimeter, if perimeter is all of the sides added together, just start on one side, h, plus b, plus h, plus b. We got to simplify this expression. That's what's happening. I see an h here, but I also see another h here. So how many h's are there altogether? This is just one h. This is one h. 1 plus 1, we have 2 h's. Let's do the same thing with our b's. We have one b and one b over here. They're both positive, so 1 plus 1, 2 b's. So the perimeter is equal to 2 times the height plus 2 times the base, b. All right, in this video, we translated and simplified algebraic expressions. This is Mrs. Struble with Struble Math. See you next time.